Hey there, Mr. Weaver here, and this is topic 4B, lesson 7, Systems of Inequalities, Word Problems. After this lesson, you need to be able to write a system of inequalities from a word problem, and you need to be able to determine if specific combinations are part of the solution set. You'll know you're successful after this lesson if you can write the system of inequalities from a word problem and convert combinations into coordinates to test them as part of the solution set. Let's look at our first example. You can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Graph the situation. First, to graph, we need to write our equations. So in that second sentence there, it says you need to earn at least $92. So that needs to be greater than or equal to 92. How are you going to earn money? Well, you're going to earn money by dog walking for $7.50 per hour and car wash attending for $6 per hour. So I'm going to write it as $7.50 D plus 6C. That way we can keep them separate. That's our first inequality. Our other inequality is dealing with that 20. It says you can work at most 20 hours, which would mean that we need it to be less than or equal to 20. So anything less than 20 is okay, or 20 is okay. How would we get this? We would get that by adding the hours of our dog walking and car washing. So D plus C. Now, if we graph those, we can use Desmos. Just remember to change them to X and Y. If we graph the first one, it looks something like this. If we graph the second one, it looks like this. Put them together where we can see the double shaded region, we would get something like that. Now, one caution with real world problems is with negatives. Here, it would be impossible to have negative hours, so we would really only look for solutions that are in that pink outlined area. Those are where both values are positive. If we go any more to the left or any more down, we're starting to get into negative hours, which can't exist. So just be careful that you are choosing values that will work for the situation. Now it's your turn. Pause the video, write the two inequalities, and graph them to show what the solution set will look like. Use Desmos for help if you need it. Let's check. First, you should have written an inequality similar to this. 12b plus 15y is greater than 120. It says more than, so it has to be that greater than symbol, not greater than or equal to. If you chose a different variable, that works as well. Second, your parents will not let you work more than 9 hours per week, so your babysitting and yard work need to be less than or equal to 9. Graphing those, the first one, more than 120, would look like this. The second one, less than 9, would look something like that. So your overlapped region is this area right here. It ends up becoming pretty skinny. So if we zoom in to where we can just see the overlap in the positive region, it would end up being just that little sliver of area where it works for both situations. Let's look at another example where we want to know if certain combinations of items are going to work for our situation. Jonah's going to the store to buy candles. Small candles cost $3.50 and large candles cost $5. He needs to buy at least 20 candles and he cannot spend more than $100. If X represents small candles and Y represents large candles, determine if the following are possible solutions. First, as we did before, let's write our inequalities and graph what they look like. So for now, I'm going to keep them as S and L so we can differentiate between our small and our large. So $3.50 for small, $5 for large. Those are both dealing with money. He can't spend more than $100, so less than or equal to 100. When we are testing our solutions later, we'll just note that S is the same as X and L is the same as Y. Our other inequality says he needs to buy at least 20 candles. So if he buys small candles and large candles together, that total has to be more than or equal to 20. Now, if we graph this situation, here I graphed it on Desmos using X instead of S, Y instead of L. I would get something like this. Just as before, I don't want to deal with any negative values because I can't have negative candles. So I zoomed in here to just the first quadrant where both values are positive. So I'm going to look for answers that are in that double shaded area. Now, to test our answers, or our combinations here, we're going to need to turn them into coordinates. So A, all it says is 5 small and 10 large candles. Well, if we think about what each is represented by, X is our small candles and Y is our large candles. If we put that as a coordinate, it would go X, comma, Y. So 5 was X and 10 was Y. Now we have a coordinate that we can test. So 5, 10 would fall in that blue shaded area, but not the red, so that would not count as a solution. If we look at the next one, we have 20 small and 5 large. We could write that as 25. For sake of time, I'm not going to show you plotting each individual. We'll do them all at the end once all the coordinates are created. If we look at the third one, notice the order switched. It's saying 8 large and 14 small candles. X is small. Even though it's listed second in the order, we still need to write it first, and Y is our large. So here we actually need to switch the order of them. So 14 would go first and 8 would go second. Same with D, 6 large and 18 small. We actually need to switch it. So 18, 6. And the last one, we have 10 small, 10 large. It's in the correct XY order, so 10 and 10. If we were to graph all these points, here's where each ends up. We can see 3 of them are clearly in that double shaded area. So 25, 18, 6, and 14, 8. So we can confidently check off B, C, and D. 5, 10, we decided earlier was definitely not. But what about the last one? 10, 10. It is on a solid line, so that's good. But is it on the border of the double shaded area? Yes, there's the double shaded area right next to it. It's on that solid border, so we would also check off E. 4 of those combinations worked so that he bought at least 20 candles and did not spend more than $100. Now it's your turn again. Pause the video, read through the situation, and test to see if each combination will work for the situation. Use Desmos if you need it, and don't forget, make sure the order of your coordinate matches what it tells you in the problem. Let's check. Your 2 inequalities should have been 0.25g plus 0.50c is less than or equal to 10, and g plus c is greater than 25. Here, g is gumballs, and when we're writing our coordinate, we'll write it as x. C is chocolate, or you could have put S for small, or Y, because that's what it tells you. If you write out each coordinate, 5 gumballs, 20 chocolates would be 520. The order should be going gumballs, then chocolates. So C and E, make sure you switched them. 10, 18, should be actually 1810, and 2010 should be 1020. If you graph them, you can see there are two of the combinations that fall in that double shaded region, 1810 and 28. So B and C. One side note, had we forgotten to switch the order for C instead of writing it as 1810, if we would have wrote 1018, 1018 would be up here in the blue area, but not in the green area. And had we not switched that order, we would have thought it did not work, when in reality, it does work. So be careful and make sure you have it in the correct order to test your coordinates. In this lesson, we learned about writing inequalities. And in context, there are two types of inequalities we're generally going to see. One format will be slope-intercept. Y is something, mx plus b. Okay, you're given the rate and the start value. We didn't see any of those examples here, but you might in the future. Though blank is put there because it could have been any of those four symbols, and you need to really look at what word is used in context to determine which one to pick. The other format could have been standard form, which we saw quite a bit here. AX plus BY somehow compares to C. Again, we're choosing our symbol based on what specific word tells us what to use. In these contextual situations, our combinations must fall in that double shaded region to work, or be on a solid borderline. When we're testing, be careful of two things. First, negatives don't really exist for a lot of situations, so read through the context and see if it can work for yours. Second, whatever it tells you the x variable represents, or whatever you decide the x represents, must be your x coordinate for your solution. And whatever you decide for the y value, or whatever it tells you, must be the y coordinate of the solution. If they're switched as choices, do the logical thing and switch them back so they stay in the correct order. If not, and we start mixing things up, we're going to get combinations that we think work that shouldn't, and that we think that don't work that should. So be real careful about keeping things consistent throughout the problem. After this lesson, do you now know how to write a system of inequalities from context? And do you know how to convert combinations, such as the large and small candles or the gumballs and chocolates, into coordinates in order to test to see if they're part of the solution set? If you're not sure about both of these things or parts of them, go back and re-watch sections of the video to help deepen your understanding. And that's the end of lesson 7 on systems of inequalities in context.